This is Mrs. Zappia with the answer key for a practice test, Grade 8, Module 3, Similarity, over Lessons 1 through 12, focusing on 8 through 12. The Level 1 question. Describe the sequence of dilation followed by congruence, which is one or more rigid motions that will map triangle ABC onto triangle A', B', C'. So the first thing I want to know is what scale factor was used. I'm going to look at the length of the sides. The length of this side is 1, and the length of the corresponding side is 2. So it looks like the scale factor is 2. I'm going to double check that using another pair of corresponding sides. So I look along the bottom of the triangle, and I see that the length of this side is 4. And the length of the corresponding side is 2, 4, 6, 8. And yes, I can see that the scale factor used is 2. So the first thing that you would have to do is to dilate the figure around point O with a scale factor R equals 2. So I'm going to go ahead and do that. That's going to move 0.11. 0.11, I'm going to take each of those coordinates and double it. And so my new coordinates are 2, 2. Then my next coordinate, this one is 1, 2. This coordinate, 1, 2. And I'm going to take each one of those coordinates and I'm going to double them. So my new coordinate is 2, 4. Over 2, up 4. Then my third coordinate is 5, 1. Then I'm going to take each of those coordinates and I'm going to double them. So my new coordinates are 10 and 2. Over to 10, up to 2. And that is my dilated figure. Now I can see that I need to translate that as well. I'm going to need to move each point over to the left 1, over 1, over 1, and over 1. And then I'm going to need to move that up 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So I need to translate left 1 and up 4. And that will map my triangle ABC onto triangle A', B', C'. Level 2 questions. Based on the information given, is triangle MRT similar to triangle M', R', T'? So I know that there are two ways to tell if they're similar. The first way is I can use the angle-angle theorem if I have two given angles that are congruent. So I'm going to look at the angles and I see that I have a 90 degree and a 90 degree. So I'm going to look for a second given angle. I see that angle M is labeled as 60 degrees on the second triangle, but not labeled on the first triangle. So I'm going to go back and figure out what that missing angle is, and I'm going to use the triangle sum theorem, which says that the sum of the three angles is 180 degrees. So I have a 90 degree angle plus a 30 degree angle plus a missing angle equals 180 degrees. The sum is 120 plus x equals 180. Solve for x by subtracting 120 from both sides of the equation, and x is equal to 60 degrees. So now I can compare corresponding angles. I have a 60 degree angle for angle M, and the corresponding angle is also 60 degrees. So I can use the angle-angle theorem to prove that these two triangles are similar. So we have the triangles are similar by angle-angle criterion. Question B. Is triangle ABC similar to triangle A', B', C'? So I'm going to look for, let's see, I have a congruent corresponding angle, 89 degrees. I have one pair. then the other angles are not labeled. So I don't know, they look similar, but you can't say for sure. So there's only one pair of congruent corresponding angles, and that is not enough information. So the answer, not enough information. They might be similar, but we don't know it. Level 3 questions. Based on the information given, is triangle RST similar to R prime, S prime, T prime? All right, so the first thing I notice is that I have a 100-degree angle in each triangle. So I have one pair of congruent angles, and that is not enough. So the next thing I want to check is, are the side lengths in proportion? So I want to look at the corresponding sides from the original figure and the dilated figure, and that would be 6.25 over 5. And then along the other side, we have the dilated of 10 over the original of 8, and I want to know if that's equal or not. So I can do the cross product. 8 times 6.25, and that's going to be this part, is equal to 10 times 5, which is the other. And this is going to give me 50. No. And this is also 50. And so the sides are in proportion. The answer is yes. Triangle RST is similar to triangle R prime, S prime, T prime. We have one pair of congruent angles and corresponding sides have the same scale factor. Question B. Determine the length of side AB. Show your work that leads to your answer. All right, so this is the side that I'm looking for, and I'm noticing that they're giving me several dimensions. The corresponding side to AB is 11.25, and then I need another pair of corresponding sides. I cannot use 3 and DF because the measurement for DF is not given, but I can use 4 and 10. So I'm going to call this my original triangle, and I'll call this my dilated triangle, and I'll set up a proportion. So I have the dilated length of 10 over 4, and on the other corresponding side I have the dilated length of 11.25 over x, and we'll let that side length be x. And then just solve your equation. So we have 4 times 11.25, which is 4 times 11 and a fourth, and we have 10x. 4 times 11 and a fourth is 45, equals 10x, divide by 10, and x is equal to 4.5. And then just look at your answer and make sure it makes sense. Notice that it should be a little bit longer than 4, and it is. Level 4. Franco is 5 1/4 feet tall. The distance from the rock to the bottom of the flagpole is 12 feet. The distance from the rock to his feet is 3.5 feet. Does he have enough information to determine the height of the flagpole? If not, explain. If so, find the height of the flagpole and show all of your steps. All right, the first thing I want to know is, are these triangles similar? So I have a triangle here, and I have a triangle here. I have a pair of corresponding angles. I have 2 pair, so I know that these are similar. I have a right angle and a right angle, and then this angle is the same on both. So by angle-angle theorem, I know that these are similar triangles. Now I can set up a proportion. Remember to use dilated over original. And I'm going to consider in this case that my small triangle is my original. So I'm going to have, let's change colors, my dilated segment and my original segment. So now I'm going to go back and get my measurements. I know that Franco is 5 1/4 feet tall. So I have 5 1/4, and that is the original number. And I know that the distance from the rock to the bottom of the flagpole is 12 feet. Okay, so that's dilated length is 12 feet. The distance from the rock to his feet is 3 1/2 feet. And that is the original length. And I am looking for the dilated height. So I'm going to go ahead and set up my proportion. I have the dilated height, and I'm going to use x over 5 1/4 is the original height. Okay, so that is these numbers. And then the second is going to be my dilated length over my original length. Dilated length on the top is 12 feet. Original length on the bottom is 3 1/2. Then I write my equation and solve it. So I have 12 times 5 1/4 is equal to 3 1/2x. 12 times 5 1/4 is 63. And bring down the 3 1/2x. Divide by the coefficient to solve the equation. Divide by 3 1/2. Divide by 3 1/2. The number divided by itself is 1. And 63 divided by 3 1/2 is 18. The height of the flagpole is 18 feet. And that concludes the answer key.